Okay, so we started last week with this slide where we were discussing, or I was discussing, the use of animals by humans today. Why does that not go away? Go away. Yeah, shouldn't it? I hope it goes away. So now I want to move on a little bit into the use of animals for research, which is the main motivation for this lecture series. But before I go into the use of animals for research, I want to give a few examples where we showed where we used to use humans for research. So humans as test subjects. This is just bothering me now because I can't see the title of the slide. So hang on, I'm gonna. Okay, we're in business now. Okay, yeah, I can see the slides. So so smallpox was one of the most, is the most virulent virus that human population has ever experienced. Really old, so this virus, variola major and minor, emerged in human populations, we think, around 10,000 years ago. If you were infected by it, sorry, one more last thing. All right, so if you're infected by it, there was two major outcomes. One is if you survived it, you're likely to be blind, and the other one was death. So it's basically a skin virus that causes these pustules, but because the pustules are so frequent, then basically your skin was no longer functioning as a barrier. It affected children quite often, so more than adults. So terrible disease. 80% of all children infected died. They estimate 300 to 500 million people died in the 20th century alone. In 1967, the World Health Organization estimated that 15 million people had contracted the disease and that 2 million had died in that one single year. Vaccination campaigns wiped out smallpox completely off the face of the earth. It's an extinct virus, and it was declared the war was over in 1979. Now, there was one small outbreak in a lab, I think in England, because they had kept some living virus in a lab environment, and there was a small outbreak. That's another story though. So the reason I'm telling you this is because of Edward Jenner. So Edward Jenner was the person who invented vaccination. And this is a picture or a painting or a drawing of him injecting James Phipps, I forget, around 7-year-old boy with smallpox. So Edward Jenner was an English physician, and he heard just from rumors, basically, that if you had caught cowpox, you couldn't get smallpox, or you had less chance of getting smallpox. And cowpox was also prevalent, but mostly in farming environments, especially people who milked cows. And there was an actual profession called a milkmaid back then. So they would hire these, usually women, that would milk cows for the farmers. And they often got these cowpox. So it was pustules on their hands. And the observation was, not scientific observation, but the societal observation was those ladies very rarely got smallpox. So Edward Jenner, just not knowing anything about anything really, he just heard that, and he took the pustule, so the pus from a cowmaid's cowpox, and he injected it into a child. And of course, cowpox wasn't very good to have either. And James Phipps was actually his gardener's son. And he got well, it's not, well, the injection alone was probably not nice for the kid, but also it's somebody's pus. So there's probably an immune reaction to that. And then there was cowpox in it. And anyway, the boy recovered from the cowpox. And then Edward Jenner injected him with smallpox, the most dangerous virus that has ever existed on Earth. Not heat inactivated, the live smallpox. The boy survived. He didn't get any smallpox. He didn't get any pustules. So Edward Jenner repeated that a few times. He did it on 20 other children, I believe, 23 other children. And he also did it 16 times or 20 times to poor James Phipps. So he just didn't do it once. He just did it over and over and over again. But this was the I mean, it was a huge discovery, vaccination, but how they did it was incredible. So vaccination comes from the Latin word vaxa for cow, and then together it's vaccinia for cowpox. That's where it comes from. I assume there's no questions. That's Gary Larson. I really like Gary Larson. So can't use humans, right? I think we'd all agree, and we probably definitely shouldn't use children if we're using humans. So what would you use? Well, animals. Why not? I mean, they're especially mammals because they're pretty close to us. So animal experimentation itself is documented as back as 300 BC. I mean, modern medicine is anchored almost entirely on experiments in animal models. One part of this lecture is about two blokes called Russell and Birch, and they were the guys who wrote, basically brought the 3 R's, so reducement, replacement, and refinement, into implementation. I'm going to tell you all about them in another set of lectures, but they said, we owe to animal experimentation many, if not most, of the benefits of modern medicine and countless advances in fundamental scientific knowledge. So they acknowledged, even though they wanted to attempt to replace animals, they acknowledged that there's really, I mean, science, biological and medical sciences are grounded in that, in using animals. So they're not useless, they're absolutely useful. And this will become clear when I'm telling you this. So Robert Boyle, a fellow Irishman, but that's not why I'm saying it. He was born in Waterford in Ireland. He was a pioneer in modern chemistry, and he came up with Boyle's law. So Boyle's law was the absolute pressure exerted by a given mass of an ideal gas is inversely proportional to the volume it occupies if the temperature and amount of gas remain unchanged within a closed system. And this is basically to make it shorter, pressure is inversely proportional to volume. And so Boyle was very interested in pressure and air, and he came up with the first vacuum pump, basically. It wasn't like vacuum pumps today, but it was like the first kind of version of it. And I don't know what they knew at the time, but I guess they didn't think that air was just space. I assume they knew that air had things in it, but Robert Boyle started to put things in his vacuum, you know, and then one of the things he put in was animals, small animals, because his vacuum was only about that size. And this is the experiment 41 that Robert Boyle wrote down in his protocol book. It's Old English, so I'll read it out, but that's the way he wrote it. And yeah, it'll become clear why I'm saying this. The bird for a while appeared lively enough, but upon a greater exsuction of the air, she began manifestly to droop and appear sick. And very soon after was taken with as violent and irregular convulsions as are wont to be observed in poultry when their heads are wrung off. For the bird threw herself over and over 2 or 3 times and died with her breast upward, her head downwards, and her neck awry. Yeah.
So the discovery of the gas wall, Boyle literally sucked the air out of a container with a living bird inside, and the bird died of suffocation.
Yeah, he did it with lots of animals. This was experiment 41.
41 of these?
No, that's not what he was famous for. He was just curious. What was that in the air? I mean, he was famous more for physical kind of things. He did a lot of things, but this was one, and it's because it's the lecture courses on the 3 years. I wanted to give that example. So basically, he had a vacuum, a not quite powerful vacuum, and he put a bird in, and the bird died. And the question is basically, why did it die? And now we know oxygen was. He put candles in and things like that as well. And then, well, we know now, it's easy to explain that the bird needed oxygen, right? That's what it died of. It didn't die of a lack of nitrogen, it died of a lack of oxygen. But years later, a guy called Joseph Wright of Derby painted this painting based on that experiment, based on that text, basically. And this is beautiful, I think. It's not a great screen here, but you look at all of these people. Now, this is people observing an animal experiment, right? And let's go through them. So this is a representation of Boyle, and this is the lark, and this is his vacuum pump. And let's go through them one by one. So see this gentleman here, he's explaining that this is science and it's really important to the child who can't look at it, yeah? And this younger child is looking at it in slight curiosity, but a bit disgusted by it, or a bit, yeah, she's emotional about it. And this is the thing with children as well. We know that the children are much more morally conscientious than adults, but unfortunately they lose it. This guy here, he's trying to be very helpful. He's trying to get a little bit of light in from the moon. It's a young man, probably impressed by Boyle. Now this is all imagined by Joseph Wright of Derby, right? There was no cameras at the time. This guy here, he's heard it all before, it looks like, and he's a bit bored by the whole thing. This guy's fascinated, and especially this guy here, you can't imagine it. She's in love with him, obviously, and he's fascinated with that. And there's a whole mix of emotions. And that's the thing also with animal experimentation. It is an emotive thing, and there's different reasons to like it, there's different reasons to dislike it. And that's what the course is about, really. So I want to give you now some examples of animal experimentation that are really famous ones. So anthrax, you all have probably heard of. So it's Bacterium Bacillus anthracis, or anthracis. It can occur in 4 forms, and it can attack the skin, the lungs, and the intestines. And Louis Pasteur was very, very famous French scientist, and pasteurization of milk is actually named after him, because he basically discovered that there was germs, that there was bacteria. Not him alone, but he's quite famous for contributing to that research, that there was basically living things that were microscopic everywhere. And he looked at chickens because he knew they had a higher body temperature than mammals, so they have a body temperature of 43 to 44 degrees Celsius. And he saw that they were immune to anthrax, and he wondered, is that because their body temperature is higher? So he lowered the body temperature of chickens. So he basically, that's pretty cold, to lower it by 7 degrees Celsius. And he found that they were now susceptible to anthrax when he injected them. So kind of cool observation. So what he went to a second species. It's always good to look at 2 species if you want to test a hypothesis that might be relevant to humans. So he heated up the anthrax germs, and he inoculated 25 sheep. And then he injected 50 sheep with the live anthrax. So all of the controlled sheep died, and all of the inoculated sheep survived. So he demonstrated that a weakened anthrax lost its virulence, but could still confer immunity. And this is interesting as well, because it's normally good to be the control animal in a toxicological experiment, but not an inoculation experiment. So in this case, the poor sheep were in the wrong group. William Roux came in the scene, they worked together, and he created what he was called a vaccine. They were obviously excited by Edward Jenner's discoveries as well. And he was working on basically on rabies, and so rabies was pretty prevalent in Ireland. We never had it, luckily, but it's pretty prevalent in main Europe, so basically wild animals foxes and wolves and rabbits and stuff had it. So they tried to they took rabbits that were infected, either they infected it themselves or they knew they were infected, and they killed the rabbits, took out the spinal cords and dried them like on a clothesline. And then they made a preparation of that, and they used it to test on dogs. And yeah, they somehow worked. It didn't work. I'm not too sure. But there was this incident then with a fellow called Joseph Meister. He was a 9-year-old boy, and he got badly bit by a rabbit, so a dog with rabies. And Pasteur Pasteur gave him this prep, which was only like vaguely tested. So Pasteur got in a bit of trouble because he wasn't a licensed physician. But the boy lived, and it was kind of a big success. I don't know if what Pasteur gave to the boy helped at all, but it didn't kill him. So that was it. So anyway, that was claimed to be another part of vaccination as well. Pavlov, who's heard of Pavlov? Yeah. So Pavlov was a physiologist, actually a physiologist of the intestinal tract, and all about learning. He was trying to learn all about digestion, and his species of choice was the dog. I guess they're easy to handle and they're really hungry all the time, so that makes them kind of useful for that. And it was inconvenient to feed the dogs when he was doing his experiments, but he wanted them to salivate. So just by accident, he saw one day that his technician, when she came, the dogs would get really excited because she came to feed the dogs. So he said to her, every time you're feeding the dogs, will you ring a bell? And so the dogs began to associate the bell noise with feeding, and then he could do his experiments without the food. I mean, he'd feed them as well. But so actually, he became quite more famous for that than what he was doing with his intestinal research, because that's what they call now the conditioned response, where you actually can condition. In humans, you can do it as well, but it's more complicated. But you can condition an animal to do something, but by an association of an expected reward or an expected punishment. He won the Nobel Prize in 1904. I forget for what, to be honest. And he used to. So these are animal experiments that were also look quite cruel, because he had an implantation or an implant in the dog's mouths that would collect the saliva. That was basically one of his assays, how much salivation was there. So you had to collect it to measure it. And then, of course, he was also dissecting the dogs and investigating their intestinal tract to see how it worked. So very important research, but it seems a bit cruel today, probably especially because we're using dogs. And if you ever want to go and see the dog, it's in the Pavlov Museum, and I don't know what city that's in, probably in Russia somewhere. Another example of a famous animal experiment is from Neil Miller's lab, and this is a rat with a ventromedial front middle part of the hippothalamus that was cut out. And if you cut out that part of the body, the animal doesn't have any satiety anymore. So they just eat and eat and eat. So he did that experiment quite a few times, and this picture became quite famous because this is his fat rat, or the VHM rat. And he didn't do anything special, except he just damaged a tiny part of the brain, and then the rat just kept eating. So that the medial hypothalamus is important for satiation, amongst other things as well. Anybody ever see this one before? No. So this was oh yeah, Kate, I forget how young you all are. So this came out in 1997, and around a few years afterwards, or actually that year and years afterwards, this got misappropriated all over the place. Fake news isn't new, and also misinformation isn't new. So there was a big uproar that, oh my God, scientists have figured out how to grow an ear in a mouse. So we genetically engineered the mouse so that it can grow a human ear. But no, I mean, the paper was open source. You could have just read it. So what's going on here is the scientists were trying to grow chondrocytes, and it's a bit difficult to do that. Well, even it's easier to do it now, but Then it was difficult to do it outside of an animal because it needs vascularization so that the cells can grow. So they put in basically a scaffold, the same shape of a human ear, and then they injected them with chondrocytes, and then they implanted that in a nude mouse who doesn't have an immune system. So there's nothing strange going on here, and it was an experiment, and it's a nice picture, but it got taken up wrong. Okay, so which animals, how many, and what for? Maybe I just ask a question. So which do you think is the most used animal currently or in the last while in research?
Rats and mice.
Yeah, that's true. You're going to say the same? And so there's no point in asking the other questions. So this is the animal breakdown from the 2013 statistics. I want one of you, I'm suggesting one of you give the update of this in your talk if it's not too boring, or in your task. So and it probably hasn't changed that much, I would suspect. So you can see mice here are 60%, rats 14%, guinea pigs, rodents, rabbits, cold-blooded animals, birds, atrio, and these guys here, which I can't pronounce, they're basically horses and donkeys. Carnivores, surprisingly, I don't know what they use carnivores for, and then they've monkeys and apes, and then they've other mammals. What do I want to say here as well? Oh, if I can't think of it, it's probably not important. So mice are by far the most used because they're small. There's other reasons as well. So it's mice and rats. That was an exam question. That's why they're hidden there. The purpose of animal experimentation. So oh yeah, what I wanted to say was the EU. I can't remember exactly when, around 2002 or 2003. This is where they're getting the statistics from. So if you do an animal experiment, you have to register, obviously. And if you use an animal, you have to write it down and file a report at the end of the year. And that's where they get this information from. But it used to be when I was starting my PhD that if you didn't use the animal for an experiment, it didn't count, which doesn't really make sense because you still have to breed them. So now you count all of the animals you use. And so, because it's not considered an experiment if you don't do anything and just euthanize it. But now that is now included as well. So you didn't do anything invasive to the animal. It's no longer in the system or whatever. So that's all useful information. So the EU are really good at collecting that information and making experimenters fill all those forms in, or they could lose their animal license at the university. So what are animals used for? So biological studies of a fundamental nature. It's very vague. So that's just research. Education and training. Now I'd be interested what the new statistics are, because I'd say that's not needed anymore, except for one field. Where do you think animals are absolutely needed for training? Two fields, actually, now that I think of it. Yeah. No, gee, computers. When I was a kid, well, it wasn't me, but in America, it was common that they would use frogs and stuff like that. But when I was a bachelor student, we had animals as training tools. There's absolutely no reason for that. You can use computers now. No reason for that. No, surgery is one, because you really have to practice on a live animal. And then don't forget veterinary medicine, because actually those animals are they're not experimental animals, they're patients. They're non-human patients. Diagnosis and disease. Production quality for veterinary medicine, production quality for products of human medicine and dentistry, research and development for human veterinary and dentistry, and here toxicology and safety assessment. Not that big actually, so 8.75%. But the special nature of toxicology is you're going to injure those animals, of course, because if you do an LD50 test or something like that, they will suffer because you're giving them toxins. So this is the part I feel we could do much better in. And this is also the reason for this lecture series. So all the rest are fine, I think, or at least that's not my beef. My beef is with this pie. So what are animals? If you take that pie, what kind of experiments are done on those animals? So there's toxicological safety evaluations, which is one of the biggest chunks. Then there's products, substances, or devices for human medicine, dentistry, and veterinary medicine, and so on and so on. So the information they provide is really, really nice. Now, if you take the disease section of the pie from the 2 slides ago, I think it's kind of obvious that human diseases will be a big chunk of that one. Cardiovascular disease, nervous diseases, cancer, and the smallest one is diseases that are specific to animals, which probably should stay because they're, again, as I said, they're the most correct species. So if you go back, so biological studies of a fundamental nature is 46% of all animals. So I'm not talking about toxicology anymore. I'm talking about that big chunk. We're using a lot of animals to predict human stuff. I mean, it's not my field, but I wonder maybe that some of that could be humanized as well. Why me? Poor mouse. Well, it's small. I mean, it's easy to handle. Short-lived. They live about 2 years. They're similar to humans. They don't look similar, but they are similar. They're physiologically similar. They're also evolutionary similar. So this is the genetic branches over time here. So obviously human is closest to the chimpanzee and the orangutan, and then the macaque, and then quite right close to that is the mouse and the rat, and then the other ones. So we're not that different to mice, to be honest. So it's a reasonable choice, I think. Now I'm half an hour and everything. So yeah, I want to now go a little bit into safety testing of chemicals and drugs and give you some historics of that. So this brings us a little bit into the realm of regulation, or how regulation used to be. And it used to be that it was a free market economy. So I develop a drug, it's up to me to make sure it's safe. But that's also good for my business. I mean, if I kill my customers, well, first of all, very few people will buy it if they hear it's going to kill you. So it makes sense, or did make sense, let's say. So let the companies just hire good scientists and do it like that. So that's the way it was. So in the 19th century, the US, I'm taking that as an example because that's the recorded one. I don't know what happened to the EU. We didn't have the EU then. A drug could be banned only after a company had been prosecuted for selling products that harmed customers. So if it was found out that you had a chemical or something, and your customers got ill, then the FDA would step in. But of course, the companies didn't want to do that anyway because, as I said, it's bad for business. If you take a look at a few of these compounds, this is a newspaper article from around then from the company Bayer, which, yeah.
Question, but so why did tobacco not get banned? Because that was obviously harmful. At least we don't have tobacco.
Tobacco was not banned because of the tobacco industry and lobbying. It was a nefarious thing they had. Yeah, so I mean, the EU is still struggling, but they broke the back of all the big tobacco companies. And I don't want to say too much in case I put this on YouTube, but yeah, it was just the tobacco industry was so powerful. It's like the oil industry. Yeah, it should have been banned. Yeah. Bayer was a pretty large pharmaceutical company back then, and this is just an advertisement. So they're advertising aspirin. So aspirin is probably one of the most produced drugs today. Even they produce hundreds of tons of it a year. It's one of the most consumed drugs as well, and it's crazy because it came into being in the 19th century somewhere, and it's I think it's probably the all-time most successful drug ever commercially, and also it's a pretty useful compound. So you can see they're advertising that here. They're also advertising heroin, and that's not a misprint or anything. They were using heroin as a sedative for coughs. I'm sure it worked brilliantly. And probably it's different if you take it orally like that. But that's a normal advertisement. They used to put cocaine in a lot of things. So they had cocaine in toothache medicines for children, or they put it in sweets. And cocaine was originally discovered. I said this wrong in the last lecture because I mixed up cocaine and cannabis. But cocaine was originally discovered in the area somewhere around Colombia, somewhere like that, where indigenous people used to use it to be able to go on longer and longer trips for hunting and stuff like that, because it gives you a false energy. So it's like a pick-me-up kind of thing. But it's also an anesthetic, a local anesthetic. So if you have a sore throat, it would be good because you wouldn't feel the sore throat anymore. But we know now that there's no country in the world I know that cocaine or heroin are legal. So it's illegal everywhere. Then what happened was in the 19th century, in the US, I already said that, didn't I? Yeah. So there was two incidences, and probably a few more, but two quite famous incidences, which changed the FDA's point of view. The second one, thalidomide, was a bit later, but this changed regulation across the entire planet. So, but let me discuss the first one first. So that's a compound called elixir sulfanilamide, and I'll get onto thalidomide afterwards if we've time. So yeah, it's just a larger view of this ad, and my point here is that they were trying to, at the time, it was I think it's kind of stopped, but medicines back then were all kind of in powder form, or maybe there was tablets as well, but it was all kind of powder kind of stuff, and they started to try and make them syrups. And because kids won't take, you know the stories of kids won't take medicine and stuff like that. So they were trying to make them attractive for kids, just to give the parents a bit of a help out. And so they would put like sweet stuff and flavors in it. And I think my next slide should be, should be about Coca-Cola. So Coca-Cola originally had cocaine in it. So the cola is the taste, the black syrupy stuff, and the coca is the cocaine. So Coca-Cola probably did give you wings like Red Bull, and they even advertise it as it relieves exhaustion. And yeah, awesome drink, I guess. Now there's no cocaine in Coca-Cola anymore, but it was until quite recently loaded with sugar, which Coca-Cola, again, like Big Tobacco, was a very, very big company, and eventually they're beginning to take the sugar out of it and have sugar substitutes. But I think companies like Coca-Cola pretty much have a big play in the diabetic epidemic, and so at least they seem to be getting more responsible. Now, but back to sulfanilamide and this incident. So I'm calling the slide and this story "A Taste of Raspberries, a Taste of Death." So Caroline Ballantine wrote a little article in June of 1981, and I'm just retelling that story. She wrote it very well. So in 1937, this thing happened. So sulfanilamide was an antibiotic, and it was very good, very useful for what we call in English strep throat, but that's caused by streptococcal infections, and children get it quite often. And it worked. It was nice. It was safe. It got rid of the infection. And as I said, there was a habit of companies to start putting these powders into syrups. That's called a new formulation in the pharmaceutical industry. So they just did a new formulation, changed its look, color, but it wasn't supposed to change its pharmacology at all. It was just to make it a little bit easier to take. In 1937, in a company called Massengill in Bristol, Tennessee, the chief chemist and pharmacist, Harold Cole Watkins, he was trying to make this elixir, and he found that he couldn't get sulfanilamide dissolved into anything. So he was in his chemistry lab and he just, everything he tried. So it wouldn't dissolve in water, it wouldn't dissolve in solvent A, B, C, D. And finally, he got it that it was dissolved in diethylene glycol. And he said, great. So then they went to test it for, you know, they did some small marketing on it. Did it taste nice, whatever. They didn't check the pharmacology again because they knew it, or they guessed it shouldn't affect it. Then they started shipping it out. So they sent out 633 shipments and sent it all over the US. On October 11, 1937, the first reports of deaths associated with taking this new syrup called elixir sulfonamide started to come in. And they basically, there was no email or anything. Basically, I think it was horse and train. All these things were being organized by. And well, anyway, somebody from the FDA or from one of the regulatory authorities asked. He said, "What's in this? What's in this thing you sent out? People are dying of it." And the head chemist said, "Well, it's sulfonamide and diethylene glycol." And they said, "You didn't put diethylene glycol in the compound that people are going to take orally." And he said, "Yeah." He didn't know it was toxic. So, you know, because there was no regulation, whatever, the man was ignorant of that toxicity of that compound, diethylene glycol. So in October 14, 1937, the Food and Drug Administration headquarters notified the deaths of 8 children and 1 adult after taking the product labeled elixir sulfonamide to the Massengill company. And that's it, cause and effect. They knew where it was coming from. Diethylene glycol, it's a compound that's metabolized by alcohol dehydrogenases in the liver. And this glycolate interferes with cellular metabolic enzymes, and it causes severe metabolic acidosis. And then part of it is metabolized again and precipitates as calcium oxalate in the kidney, causing precipitates in the nephrons and causes acute kidney failure. And that's painful and quick. Well, not quick, it's a painful way to die, terrible way to die. In the end, 100 people died. The lead chemist couldn't forgive himself for simple ignorance. He didn't have any bad intent, but he couldn't take it. Most of the 100 people who died were children. And you have to remember as well that a lot of GPs, so a house doctor or general practitioner or your just family doctor, they had given their customers this as well. And again, because it was a sore throat thing, it was mostly children. So I don't know, I feel sorry for them as well. So it's a bad story. Everybody involved, it was terrible. So the chemist committed suicide. There were so many cases brought about Massengill that they collapsed. And in 1938, the Federal Food, Drug and Cosmetic Act required proof of safety before the release of a new drug. We'll take a break after this story. So this is a story about another drug in 1950, which was also a calamity of errors. Hands up who's heard of any one of these names: thalidomide, Contergan, Sofenon, I just heard that today, and Distaval. What do you know it is?
I thought it was about the pregnancy.
Now, what do you know, that which chemical name do you know it is?
I think
Thalidomide.
Yes, Softenon.
Softenon, that's in the Netherlands, yeah. Sorry? Okay, and you, Johnny? Yeah. So I lived in Austria, so I wasn't around then. I was born in 1974. But when I asked people, it was Contergan, they mostly knew it of. In America, it was mostly thalidomide, but there was loads of different names, which actually makes this thing a bit confusing as well. But the scientific name is thalidomide, or at least that's the consensus. So thalidomide, or in German, or what all the other names, it's a teratogenic compound. So it was developed by a German pharmaceutical company called Grünenthal, and they released it as a sedative in 1957. Right? Its development was as a sedative. So it started to be used as off-label, so not what it was intended for morning sickness. And this is the danger of using something off-label. I don't believe the company knew about it, to be honest. I don't think they wanted it. They certainly didn't advertise it like that. If I remember correctly, or I hope I didn't hear incorrectly also, I think it was an Australian physician that started giving it to some of his patients for morning sickness, again, completely off-label. It said nowhere on those packages that they should be given to pregnant women. And they found it relieved their morning sickness. And then just by a rumor mill, it got around the world and people started using it for that. I assume people started selling it for that at some time as well, but I don't know. I really don't know if Grunenthal were implicated in that because it wasn't developed for that purpose. In the late 1950s and early 1960s, more than 10,000 children in 46 countries were born with really severe deformities. And we will never know how many babies or fetuses didn't survive gestation. So you could imagine that it must be hundreds of thousands, but it's hard to know. I mean, I guess we'd have to know how many people took it, but we also don't know that for sure. Several countries never approved the drug. Austria was one. I think also America was one. But people still got it in Austria because you could, you know, if it was a good drug and your auntie had it in Germany, you should send it to you by post or whatever. But it wasn't prescribed in Austria, and I don't think also in Germany. It was withdrawn in 1961. So this is a quick action, 4 years. That's fast by modern day standards also. So when you look at the advertisements for thalidomide or Distaval or whatever name it is in your jurisdiction, it was all about safety. They promoted it as a safety compound because there was a habit of people to take barbiturates at the time. And we didn't have child locks on our medicines. So a lot of children got poisoned with the barbiturates. They're really toxic. And this thalidomide was absolutely not toxic to children. It was safe. And just by extension, it was very safe for use by adults as well, except if you were pregnant, because it was not safe to the developing fetus. This is an example of another ad, a complete sedative and hypnotic range in a single preparation. That is Distaval, the safe daytime sedative, which is equally safe in hypnotic doses by night. Distaval is especially suitable for infants, the aged, and patients under severe emotional stress. Could have used that last year. So it was sold as a safe product to relieve people's anxiety, you know, and much better than barbiturates at the time, which were kind of nasty compounds. So thalidomide, that's what it looks like. It's a kind of a glutamate. I'm not a chemist, and I don't have a chemistry eye, but it's a derivative of glutamate, which is this neurotransmitter in the brain. It's lipid soluble, therefore, unfortunately, it really readily crosses the plasma membrane. That's not the only reason, but it helps. So it gets quickly across the placenta. The placenta does act as a barrier for lots of things, but some compounds goes across. Its mode of tetragenicity is not fully elucidated. There's loads and loads of hypotheses. And yeah, pick one of your favorite one, it doesn't matter. It is a teratogen. It does prevent proper formation of a healthy fetus. Oh, I don't remember this slide. This is about mechanism. The precise mechanism of action for thalidomide is not known, although efforts to identify thalidomide's teratogenic action generated 2,000 research papers and proposals 15 or 16 plausible mechanisms. Okay, so this is about this mechanism. What was the outcome of the thalidomide disaster? So, as I said, really quickly, it was stopped, prohibited, and never to be sold again, which isn't quite the truth. Now I'm saying it because it was beginning to be used in the last decade for leprosy, but I'll come back to that. So basically, it started an amendment. So regulation is all about incidences and amendments, because that's the way it works, because you didn't think of something, so you just add on to it. And then other countries can borrow or learn from what happens in a neighboring country or even a distant country. So what happened in America, it was the Cooper-Harris Drug Amendments Act was instigated in 1962. And the legislators tightened the restrictions surrounding the surveillance and approval of drugs to be sold in the US. For any drug that might be taken by a pregnant woman, there will be emphasis on the testing in pregnant animals of several species called reproductive toxicology. So this incident brought reproductive toxicology into the regulatory domain, and you had to check it. And this is where rabbits came in as test animals, because for reasons we don't really know, or at least reasons I don't really know, if you tested thalidomide on rats and mice today, they're not affected by it. So they found out that rabbits were, and actually zebrafish are as well. And zebrafish is used as a reproductive tox model. So rabbits and rabbits are not rodents, I found out. So it's a completely different lineage. And so rabbits and zebrafish are used for reproductive toxicity testing. So are mice and rats, by the way. It's not that, it was just for thalidomide that rabbits weren't working. Sorry, rats and mice weren't working. And then this came into statement. So Cambridge University's Dr. Woolam offered this universal prescription, which I think was a very clever and pragmatic solution, which is pretty much followed today as well. In the present state of our knowledge, that was in 1962, and probably it's the same today, the only safe course is to bar absolutely the use of new drugs by women who are believed to be in the early stages of pregnancy. So brilliant advice. The only problem is you generally don't know you're in the early stages of pregnancy when it's the most risky time. So basically, they should have said, if you're thinking of becoming pregnant, or if you're not using contraception, then you probably should stay away from any new drugs, and also read the packets of the ones you're using. This, on a side, this is also why women are not really used in phase 1 clinical trials, because of that risk. So I heard silly people tell me that the drugs were developed for men because of this. It's stupid. I mean, it's phase 1 clinical trials is just a quick check. Well, it's not. It can be quite complicated, but they're generally healthy volunteers, and you don't want to risk, because even a pregnancy test will only work a bit later. So you just don't want to risk that extra liability. That's all. Also, hormonal things can affect some medicines as well. But yeah. So what about thalidomide today? So I said that thalidomide was basically banned and then starting to be used for leprosy, but in developing countries. It's a terrible word, isn't it? Developing countries, in poorer countries, abused countries. It's sad, isn't it? Because people get pregnant there too. So they started to have instances again of new thalidomide things because it was being used there. So the World Health Organization does not recommend the use of thalidomide in leprosy. I think it was the only thing it was still used for, and they recommend another course. And here's what they wrote, which is nice. Experience has shown that it is virtually impossible to develop and implement a foolproof surveillance mechanism to combat misuse of this drug, thalidomide. Today, a number of thalidomide babies continue to be born each year, reflecting regulatory insufficiency and widespread use under inadequate supervision. So it should be put in a box and deleted, basically. We'll have a coffee break and then we'll come back and talk about the interesting topic of animal ethics. Okay, so it's recording again. Any questions so far? No? Let's go to it then. So animal ethics. So this is a quote from Jacob Brovonsky, and it's quite poignant. So if you don't take anything from this lecture, take this home. Those who think that science is ethically neutral confuse the findings of science which are with the activity of science which is not. So individual scientists, now let's take ethics out of the question for a second. Individual scientists, for example, can be extremely biased and can imagine, an experiment or how the world will work. But that's also okay. But science as a whole, because it's consensus based, because my opinion will conflict with somebody else's until we know basically what's going on with that particular biological system. So that's all right. But the same thing applies to ethics. So individual scientists or individual experiments can be unethically conducted, and ethics changes with time as well. So I don't think too many people really were worried that much what Edward Jenner did. It's hard to know because there was no Facebook back then. But I look back on Edward Jenner's experiment, and you have to remember he's probably saved billions of people's lives because vaccination is so important for child mortality prevention. And that's also why you need to have less children these days, because in my parents' generation, in Ireland at least, it was a poor country then, it was normal to have 10 or 11 children, because not all of them will survive. So with vaccination, child mortality really, really dropped. I mean, tremendously. And then with pediatrics and stuff like that, and improved birth safety. But I still find it conflicting, because what Edward Jenner did is completely, incredibly bad manners and unethical. He injected 20 children with the most dangerous virus that ever existed. He knew full well it was dangerous. Also, cowpox is a living virus as well, which was dangerous. So even the inoculation itself was dangerous. And there's no documentation that any of those children got injured. But how could he know? They didn't know about viruses. They didn't know a damn thing about them back then. And yeah, okay, brave maybe, but I don't know. Who is he being brave for? Because it wasn't his life he was risking. And if it didn't work, we wouldn't be talking about him. So it wasn't like he had a reputation to lose either. So I don't know. Basically, I'm telling you, you can't do that anymore. And ethics is a thing that changes over time anyway. So maybe if they had discussed it a bit more, thought about ethics back then, they probably wouldn't have done it. So the end does not justify the means, to my mind. I think most people think like that now. That's why ethics changes. So just read it out one more time. Those who think that science is ethically neutral confuse the findings of science, which are, with the activity of science, which is not. And I can think of multiple examples, like there was experiments done during the Holocaust, which the scientific community decided to just delete. They might have been useful for human physiology, but the way they were done was just atrocious. There was a lot of cruelty involved in those kind of experiments. So what is ethics? So it's a set of moral principles that governs a person's behavior or the conducting of an activity. The term morality refers to a body of learnable standards of rights and wrongs, or right and wrong conduct, so widely shared in society that they are from a secure communal consensus. So it's all about consensus. So the majority of the people feel like that. That's what ethics is. And they stop rogue people, especially in science, rogue scientists doing unethical experiments, because if you do experiments on animals or humans, there's a whole ethical board you have to go through. Even for me, using cells in my lab, there's ethical principles we have to obey, like we have to make sure that the donor isn't traceable, and these kind of things. So I pulled this from this book from Orland's and a group of scientists who wrote a book. There's lots of books written about ethics, but this was specifically about the use of animals, so I thought it was a bit more specific. But so they defined a set of 10 rules that should apply to animal experiments. And this is open to discussion, because if ethics is about consensus, let's see what this means. Now, I think they took 10 on purpose because of the 10 commandments. So, and they're actually quite close to the 10 commandments, actually, because that was also an ethical moral code. So I'm a Catholic by birth, not by choice. And I don't know, I'm sure other religions like the Quran might have something similar in. So let's go through them one by one. And think about what these mean for an experiment, right? Or for the use of an animal. Tell the truth. Anybody? Well, you want to tell the ethical board or the person that's involved or the animal what you're doing. Why? Right, so that's telling the truth. Also, you shouldn't lie about the results, which happens quite a lot. You should do the experiment in such a good fundamental way that the results are valuable and are of value. But I mean, animals don't understand human languages, so we can't tell them the truth. Respect the privacy of others. Yeah.
So this was drafted as a work code to use in animal research.
No, ethics is not anything.
With some slides because we just covered. So.
Yeah. No. It was from a book discussing ethics, the human use of animals, basically, and the ethics codes in that. So you can apply ethics to anything. So again, ethics is a discussion. And when they were writing that, they wrote this down. It's not a rule book. It's just that was the discussion they came up with. And I want to have a discussion with you, or at least I want to tell you what I think about this. So respect the privacy of others. So this is really, now we know that. See, that's the thing. It changes so much, but that's now entrenched in the EU regulation with the GDPR. And we always have to now say, yes, we accept the cookies, but we never read what we're accepting. But anyway, so the EU is very good at that. I mean, they've even now the right to be forgotten. So you can delete your own, what people say about you on the internet if you choose. And you can delete your Facebooks. Before it was just like, nobody could see it. It wasn't deleted. But now they have to prove that it's actually deleted. And in medical science, that's so important because the information you might have from a person could have implications for them, for their insurance, just as an example. Or let's say one of you come to me, I'm a medical doctor, and I find out you have a genetic disease. So that means likely people in your family would be affected. And you might not want, I mean, it would be good if you told them, but you might not want to worry them or something like that. Maybe it's incurable or something. So, I mean, I know in the US, there is this thing that if you have a predisposition, your insurance, sometimes you're not insurable. So if you're a young person, for example, and you go to the doctor and they find out you have a genetic disease that will only materialize when you're 50, the insurance companies won't take you on because I mean, it's ridiculous. That doesn't happen in Europe. They're not allowed to do that. But you know, governments change. I mean, how many times have governments changed, or bad governments happened in Europe over the last 100 years? So it can go back again. So, and now if I take a cell from you, I mean, we discussed Charlie probably going to work in my lab, and she's going to grow her own cells. If I genotyped all Charlie's cells, I know everything about your entire history from now back 3.5 billion years ago. So I know all about you just by looking at your genome, and I can do that for a few €1,000. I won't know what to do with it, Charlie, and we won't do it anyway. But so we can produce a lot of data from very tiny amounts of samples now. So we have to be very careful with that information. This is also about confidentiality. I mean, all these things go hand in hand with each other, but so that you also wouldn't want, you know, it's a bit difficult with the COVID because everybody's so happy to say I'm at home with COVID, but I mean, I don't think at the beginning people were that happy to say you had COVID because you'd be treated more poorly by everybody else, and you'd be ostracized, and they'd be checking that you are home for 2 weeks, and nobody would bring you food and stuff like that. So it's different now with the Omicron, but so yeah, the information should be confidential. I mean, that was the thing with in the Catholic religion. Well, at least in Ireland, it's not very regular anymore. But you used to go and tell your priest your sins, and he would keep it confidential. You could even say you murdered somebody, and he wasn't supposed to tell anybody. It's the same with lawyers. But my mindset now here is really doctors and scientists. Obtain consent before invading a person's body. I mean, the obvious example of that is rape. I think nobody thinks this is a good thing, but if you think about an animal, we don't ask them for consent before we kill them or do surgeries on them. I mean, it's different if it's a pet and you're doing it for a reason for their health, but if it's an experiment that they get no value out of, then it's a consideration. It's a complicated consideration because they can't really give consent. Do not kill. Well, in toxicological experiments, even the controls are killed. because you have something to compare it to. So it doesn't matter. The controls don't suffer. So we think, so modern ethics, modern day scientists, I feel as well that killing the animal is okay. Making it suffer before, I don't find that okay. But sometimes you have to do it. And we'll get back to that as well. Because I'm a meat eater. So I really have no problem with that. I mean, it's sad. I've seen it happen. I've been in an abattoir where baby sheep were killed. Because in Ireland, we eat the lambs because they're tastier. And it was awful. I mean, it really was awful. I still eat lambs. Do not cause pain. Well, that really goes into toxicology because at the highest concentration of a compound that's toxic, those animals really suffer, depending on the nature of the toxin. Do not deprive of goods. Do not incapacitate. We put them in cages, for God's sake. Oh, we have to, otherwise they're not going to hang around. Yeah. But we'll get back to that as well, about enrichment of their environment. But I don't think people really notice. If you take a wild rat, and put it in a cage, it'll die, even if you feed it with water and stuff like that, because it's stressed all the time. So those animals we have in our cages, they were genetically inbred by accident. It's like the self-evolution by accident, because all the ones that were nervous died, and only the docile ones lived, and then we bred them together. So the ones we have now are really, really docile animals. Then you can pick them up and hug them and stuff. I mean, you can also have rats and mice as pets, but they are also the docile ones of that. Protect and defend the rights of others. Well, animals, are we protecting them? I mean, many people think that's one of the reasons I'm giving this lecture as well. We should consider, we should probably protect them to where we can, and prevent harm occurring to others. So that was their 10 points. Any conversations on that? Do animals deserve protection? And if you believe they do, why? So before we knew about the brain, it was a discussed thing. I mean, this is going back 50, 60 years ago. It was discussed. Do they have a moral sense? So are they conscious? Do they have a conscience? Are they self-aware? Do they have the ability to suffer and feel pain? Are human rights higher than animals? And why? I'll address a few of these things. Why does it matter if they have a moral sense? I think that's a silly statement. I mean, if you take somebody who murdered somebody and you put them to prison, I still think you shouldn't murder that person. And that's what happens in Europe. It's different in America, but it's, I think, changing in America. So I think the morality of the victim, or even the person who committed the crime, shouldn't change the way you treat them, in my opinion. Are animals self-aware? Again, this is a bit of a gray one, because I think they mean by that, are they aware that they exist in a human way? Well, again, does it really matter? Are they self-aware? Of course, they eat, they drink, they reproduce, they have sexual interest. Otherwise, well, most of them do, otherwise the species wouldn't exist. They make friendships inside their own species, outside their own species. Of course, they're self-aware. I can give you many examples where the animals dislike the technician or like the technician, and would change the experiments. We'll get back to that. There were some of the experiments done by chance. Are they able to suffer and feel pain? Well, God, we know they are. I mean, all the donkey sanctuaries and all that kind of stuff. So animals can suffer and feel pain. But now we're thinking about mice and rats. But what about a worm? Can a worm with a very, very, very rudimentary nervous system, can it feel pain? Can zebrafish feel pain? So, and if they can't, does that mean we could do experiments on them and we couldn't do on other animals? I don't know. They're more complicated questions. But if you take a rat, it will feel pain, of course, and it will suffer, and it will stop eating. I mean, they had this experiment where they put rats in a cage alone, made them feel a bit unhappy, and gave them a little lever, and it would release a drug like cocaine, I think, but a drug that would, no, I think it was an opioid, but anyway, a drug that would make them feel good. And they would just do that. They wouldn't eat water or anything. They would just keep doing that because they were shown to be miserable. and they've just kept doing that. So yeah, they can feel pain, they can get depressed, they can suffer, and that's obvious. Can we justify animal use? And one thing I wanted to say here, are human rights higher than animals? Well, obviously it's a case. So we have burgers and we have chickens and we eat meat. Not everybody, but we in modern day societies, the ethical code is that human rights are higher than animals. Now we have a subculture in our human societies, vegans basically, who are against the use of animals for all purposes, including to take as pets. And they would suggest that animal rights are higher than humans, actually. Organizations, which I won't go into, but there has been animal rights activists, so bad players in that movement have planted bombs and killed people for the protection of animals. So they think, or some of them think that animals have higher rights than humans. So you get all sorts of people thinking of different things. And the ethics is sort of kind of to average all of that into a middle consensus. Can we justify animal use in all cases? Where are the exceptions, if any? And that's kind of the question. So this is more of a discussion idea. So does anybody have a feeling about this? These are all of the examples of using animals I could think of. Can we justify all of these? You as single people, from your own perspective. Is anybody here against any one of these things here?
It's really easy now to use vegan leather. So
Yeah. Also, we don't need leather. We can use plastic.
that's true.
But I'm surprised that you didn't say cockfighting, because
Oh,
I thought
yes.
everybody would be against cockfighting. So that's banned in
Why is
most,
there a pronoun issue?
because it was used in teaching.
I-
Yeah. So I'm against that. I know lots of people lovely people, very good people who have horses, for example. I don't think there's anything wrong with that either, to be honest. I'm not too sure about horse racing. I mean, it's a great sport and it's good to watch and it's nice to bet money on the horses, but the accidents they have seems, I don't know. So I'm not clear on some of these things. Yeah, I think you get things,
And why is there a cat in the picture?
pets.
Aye.
So vegans would have us not have pets. And I don't like that. I would like to have pets. So yeah, the leather jackets, I agree with you, but I like leather boots. I love Doc Martens.
They're vegan now too. They're vegan leather.
Can you get it from Doc Martens?
Yes. Yeah.
And they look the same.
Yeah, they look exactly the same, and they say that the quality is even better because mine goes now with balls in it.
Well, now let's discuss that.
It doesn't
Yeah,
matter.
so let's discuss that then. So leather. So are animals killed for leather?
Yes.
No, they're not killed for leather. They're killed for meat.
Yeah.
So it's different for the fur coats. So the minks, they're killed but so the cows are killed for their meat. They're not killed for the leather.
Oh, it's just.
And so actually having a vegan shoe means that piece of the animal is thrown away. So actually that's anti-animal rights to my mind. It's just a marketing ploy. Although if I was a vegan, I'd be very uncomfortable wearing leather shoes, I have to admit. But I'm not a vegan, so I have no problem wearing leather shoes. In fact, I prefer leather shoes. Anybody else? Any comments? Eggs. Anybody got anything against eggs? One of the most nutritious foodstuffs one could imagine. Chicken lays it all the time.
Don't they check and make sure that they don't actually use eggs that are fertilized? They always use unfertilized eggs.
What's the easiest way not to have an egg fertilized?
Sterilized chicken.
No, don't have a male chicken around.
Aye.
So they don't have male chickens, so they don't have to. They just don't give them the opportunity. So okay, maybe that's. So you deny the female chickens of sex, but if you ever see chickens copulate, it's pretty violent anyway. So
Like the cockfight.
no. Well, yeah. Well, let's not get into that. So yeah. So eggs. Let's discuss eggs. Anybody got a point of eggs? Who here eats eggs? nearly everybody. That's the cool thing about eggs. It's one single cell. It's the biggest cell you can think of. Well, I heard. What about battery farms where most of the eggs are produced? Do you not think that's bad? The way the chickens are kept. Yeah, you're nodding. You're all tired. So, yeah, it depends. I mean, the eggs themselves, but it's, the way the chickens are kept is really important. I mean, these huge industrial chicken farms are terrible. So I wouldn't want to eat eggs from them. I'd rather not eat eggs at all. But I see in the Netherlands here you have these 3-star to Beta Leven, and I always buy the ones with the 3 stars, and they're quite correctly more expensive because they're more expensive to produce. So I buy those ones all the time. It makes me feel a bit better. But the chicken doesn't suffer by producing the egg. The chicken suffers by the intensive nature of that farming, which to my mind is not necessary. Now, chicken meat is a completely different story, but what else is on here? Well, I think that's it. So we could begin next Monday with topic 2. I'm going to just stop this. Hang on. Don't go away. I want to talk to you. Yeah, I'm just tired now at this stage. Where is it? Top. No. Where? Top left. Oh yeah. They keep moving them around.